This video is day 5 video, the first day of our second week, March 30th, 2020. We're going to do module 14, which is logarithms. What is a logarithm? Well, if I have an exponential function, 2 to the y is, let's say, equal to 8. And I'd like to find the inverse of that function. Well, first, before I'd say that, the 2 is the base. This is exponential form. The y is the exponent. And the 8 we'll call the number. And you just need to remember the position of those three things. And we're going to convert it into logarithmic form by doing what's called a logarithm. So we got a base, we got an exponent, and a number. The logarithm is the inverse of the exponential function. So I'm going to take the log of, and there's going to be a subscript here, and that subscript is going to be the base. So every log is going to have a base. It's kind of a bad looking B. Keep hitting a button here. And I take the log of a number, and every log is equal to exponent. So basically logs are exponents. Well, I shouldn't be writing exponent there. The exponent is y. So every log is equal to an exponent. So we take the log of a number, and every log will have a base, and the log is equal to an exponent. So I can write any, and 2 to the what is equal to y? Well, 2 to the third is equal to 8. I said y. So if I take the log base 2 of 8, it is equal to 3, or the base 2 raised to the exponent 3 equals the number 8. So what we're going to do first is just get comfortable with converting from logarithmic to exponential form. So if I've got 6 to the third, which is equal to 216, I'm going to ask you to express that in logarithmic form. So you're just going to write log, and that log must have a base. The base is going to be 6. I take the log of a number, so that would be 216, and that's equal to the exponent 3. 5 to the x is equal to anything. You can say 8. So log base is the 5. I take the log of a number, which is 8, and it will always equal the exponent. I could say 3 to the second is equal to y. Logarithmic form, log, my base will be 3, of the number y is equal to the exponent 2. So it doesn't matter where you have variables, you're just converting the form, log base exponent. And of course, we can go the other way. So I'm going to tell you to express it in logarithmic form. So if I give you something that says log base 3, one shouldn't be there. Log base 3 of 81 is equal to 4. Convert that to exponential form. Well, the log has a base of 3. Every log is equal to an exponent, so 3 to the fourth is equal to 81. So if you start looking at logarithmic form just as an exponent, base, exponent, number. Log base 121 of 11 is equal to 1/2. It doesn't matter if there's fractions. Exponential form, the base is 121. The exponent is what it's equal to, 1/2, and my number is 11. So 121 to the 1/2 we all know is the square root of 121, which is equal to 11. This is what we're looking for, though, if I just converted it to exponential form. So log base 3 of x is equal to 10. Writing in exponential form, base of 3, exponent of 10 is equal to the number x. All right, and the final thing I'm going to do on this video is just ask you to evaluate this logarithmic expression. So if I say evaluate, this must equal some value. So if it just says evaluate, just make it equal to some value. Rewrite it in exponential form. Base 5 raised to the exponent x is equal to 25. Now we all know what that equals, but let's do it a different way. 25 can be rewritten as 5 squared. So if your bases are equal, then your exponents have to be equal. So log base 5 of 25 is equal to 2. Same thing here. Evaluate this. Well, that must be equal to some value x. 6 to the x is equal to the number 10. Whoopsies. Because we have a base, an exponent, and a number. Again, like bases, exponents must be equal. Let's try it here. 5, well, this equals something. So 5 to the x is equal to the cube root of 5. Well, now we need to convert from a radical form into an exponential form. The index is the denominator, the power is the numerator. So that's 5 to the 1/3. Like bases, x is equal to 1/3. Finally, we've got this value. We want to evaluate it. So I'm going to say 2 to the x is equal to 1/16. Well, I can rewrite 16 as a power of 2. And in fact, that's going to be 2 to the 4th. But it has to have a base of 2, not 1 over a base of 2. So 2 to the x is equal to 2 to the negative 4 by bringing it up from the denominator. So x is equal to negative 4. And that's all there is. Again, this is for Monday, the 30th of March. We'll put some problems up on Google Classroom. If you have any questions, please don't hesitate to ask. All right, guys, I'll see you in the next